Come on. Yes. Okay. Today we are learning the last thing that we need to know in order to take our quiz next week. So today we're learning about dilations. And so all of our transformations so far have been something called congruence transformations, which is where it leaves the shape the same as just moving it around in the space. But dilations is the first one that does not leave your shape exactly the same. So what we want to be able to do today is dilate a shape about the origin and determine the scale factor of a dilation. So before we get really into dilations off of a graph, we want to talk about kind of the sort of transformation that a dilation is. So we're going to use Mickey Mouse as an example. So have you guys ever done like a project where you needed a picture for something and you just like dragged the side and it ended up looking kind of funny, did a kind of a bad dilation? And then you realize, oh, if I drag the corner, it keeps everything proportionate. So anytime I drag the corner, we're keeping everything proportionate, and that's what dilation is doing. When we do a dilation in geometry in the coordinate plane or anywhere else, we keep things proportionate because we don't want to end up with something that looks completely different. We just want to end up with something that looks larger or smaller. But if you shrink it up like that, then all of a sudden you end up with a short, fat Mickey or a tall, skinny one, where you probably wanted to actually preserve the dimensions by dragging the corner. Okay, not a lot of love for Mickey? Okay. Yikes. He's a monster. Is it the mouse's fault or the folks at the lovely Disney company? Anyway. It's the mouse's fault. All right. Anyway, that was to kind of illustrate what a dilation is doing. We're making something larger or we're making something smaller, but we're keeping the same proportions to it. So go ahead and grab whatever you're using to take notes, and let's get started. Delete the mouse. All right, we'll delete the mouse. Okay. So dilation 4.5. Yes, hopefully people use notebooks to take notes or paper or something like that, you know, not writing your notes on your forearm. Anyway, dilation is where you make a shape bigger or smaller given a scale factor and a center of dilation. Given a scale factor and a center of dilation. And this dilation process will preserve proportions. So it will still look proportionate. It's not going to make your shape, you know, short and fat or tall and skinny or anything like that unless it is already one of those things. Okay, so we need to talk about the scale factor and the center of dilation here. First, the scale factor. Okay, so the scale factor tells us how much bigger or smaller we're going to make our shape. And it's going to be using multiplication to do how many times bigger or smaller is it going to be? So if my scale factor was 2, it would be 2 times bigger. Okay, so a couple of rules here, or general things that happen. If your scale factor, I'm going to call it SF, if your scale factor is bigger than 1, or we'll say the absolute value of your scale factor, because you could have a negative scale factor, but that's also going to be considered an enlargement. So if the absolute value of your scale factor is bigger than 1, that's an enlargement. We're making it bigger. If your scale factor is between 0 and 1, then that's going to be a reduction. So if you have a fraction that's less than 1 as your scale factor, that's going to be making it smaller. So we have enlargements, we have reductions, making it bigger, making it smaller. And the place that people tend to mess up with figuring out if something is an enlargement or a reduction is they don't read which shape comes first. You need to make sure that you pay attention to which shape you start with and which shape you end with. Okay, so that's scale factor. The other thing we talked about is the center of dilation. So the center of dilation is where you're dilating from. So it's kind of your starting point. For us, it will be the origin typically. So it's not all that different to dilate about different points besides the origin, but the origin will be the easiest point to dilate from. And so that's what we are going to use a vast majority of the time. Okay, center of dilation for us will be the origin. So we've talked about scale factor, we've talked about center of dilation. Let's do an example in which we do a dilation. So just like yesterday, this is going to involve some graphing, so drawing coordinate planes and all that good fun stuff. So first example, we're going to make ourselves a nice coordinate plane. And then we're going to plot our original shape in the coordinate plane. So our first point is going to be at 3, 2. Our second point will be at 3, negative 2. Our third point will be at 0, negative 3. And our fourth point will be at negative 2, 3. Okay, and then we'll connect the dots. So there's our original shape, and we're going to be asked to dilate ABCD about the origin with a scale factor of 2. Dilated about the origin with a scale factor of 2. So this would be the complete set of instructions that we would be given, and we want to know what to do with these. So first, I kind of want to pull apart the problem a little bit and notice that our scale factor is 2. So if our scale factor is 2, is this thing going to be getting bigger or smaller? Yes, Caleb, that is where we are headed. Well, if our scale factor is 2, scale factor greater than 1 is an enlargement. So yes, this thing is going to be getting bigger. And then we notice it's also, that means it's going to be 2 times bigger. Some other notation that we might see instead for our set of instructions, we could see something like xy going to 2x, 2y. You could see something like that. Because basically when you are dilating about the origin, the nice thing that happens is that you can just multiply the coordinates by whatever your scale factor is. So since I'm dilating about the origin and my scale factor is 2, I can just take all of my coordinates and multiply them by 2. So instead of these coordinates, my new ones would just be multiplied by 2. So a prime would be 6, 4. B prime would be 6, negative 4. 0 times 2 is still 0. So C prime would be 0. And then negative 6. And then D prime would be negative 4, 6. So all I'm doing there is multiplying my coordinates by 2. Even if you're doing this without writing it down, really, you can notice that this is point A is over 3 up 2. So instead of over 3 up 2, it'll be over 6 up 4. For B, instead of over 3 down 2, it'll be over 6 down 4. For C prime, instead of just down 3, it's going to be down 6. And for D prime, instead of over 2 up 3, it'll be over 4 up 6. And then we would connect the dots. So those are kind of 2 ways you can think about it. You can think about it as just multiplying your coordinates and then graphing your new points. Or you can think of it as starting at your center of dilation. Well, I went over 3 up 2. So then I have to go over 6 up 4. You're just multiplying your instructions. However you want to do it is fine. But yeah, that's the general idea here. Also, something that we could notice, if I'm just given the picture and I'm not told that the scale factor is 2, something that we could do to find the scale factor is I could count the side lengths, like this one here. So if I was going to count the side length, it would be 1, 2, 3, 4. This side length is 4. And then 1, 2, 3, 4, 5, 6, 7, 8. This side length is 8. So even if I didn't know the scale factor and I was given this picture of both of these shapes, I could figure out that 8 over 4 is 2, so my scale factor would be 2. Not much. So my scale factor is also just a ratio of the side lengths from my new shape to my old shape. Okay. Any questions so far? Any numbers we're not sure where they came from? Any steps we're not sure how or why they happened? Okay. So the next one I'll show you is probably the most complicated that this gets, and it's not even that much more complicated. So we multiply the, so for finding the shape itself, you just multiply the coordinates by 2 since the scale factor was 2. What I was talking about down here was if I didn't know the scale factor, but I was shown these two shapes, I could find the scale factor by dividing the new shape by the old shape on the side lengths. So that's something that you could do if this would be like a separate problem though. The original one, all you have to do is multiply the coordinates by 2 to get your new coordinates. And we'll talk a little bit more about this exactly later in a different example. Okay. Second example. We're going to learn what to do if our scale factor is a fraction. And of course, we are going to need a coordinate plane. And we're going to go all the way out to 6 on these. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And for this one, my first point is going to be negative 6, 3. Over negative 6, up 3. Second point is going to be 6, 6. So over 6, up 6. And then my third point is going to be 0, negative 3. All right, so there's our original shape. Here's our instructions. Dilate ABC about the origin with scale factor of negative 1/3. Okay. So the process for this is going to remain the same as the last one. So don't let the fraction freak you out. The alternate instructions to this might look something like this. X comma y to negative 1/3 x, negative 1/3 y. So really all we're doing here is still just multiplying your coordinates by whatever your scale factor happens to be. In this case, since our scale factor is negative 1/3, you could also think of this as dividing your coordinates by negative 3. So multiply by -1/3 or divide by -3, that's doing the same thing. So if I start off with my coordinates, A, -6, 3, B is 6, 6, and C as 0, -3, what I want to do is divide each of my coordinates by -3. So A prime, well, -6 divided by -3 is +2. 3 divided by -3 is -1. So that would be my new coordinate for A prime. For B, B prime is going to be -2, -2, because 6 divided by -3 is -2. For C prime, 0 divided by anything is 0. -3 divided by -3 is +1. Okay. So then, all we have to do is plot those points. So A prime is 2, -1. Yes, it flips the shape. Nice, Philip. Anytime you have your scale factor being negative, it flips the shape over, specifically reflects it over the x-axis. So yeah, that's an added feature of having a negative scale factor. So there's A prime. B prime is -2, -2. And then C prime was 0, 1. So yeah, this would be our new shape here. So it shrinks it with a scale factor of 3 and it flips it over, reflects it over the x-axis. So yeah, that's something we can notice about a negative scale factor. Reflects it. Yeah, so it flips the shape over. Or actually not quite reflected over the x-axis. Sorry about that. It does flip it, but it doesn't flip it directly over the x. It let's see, what does it do? It does here, this would be here, here. I believe it reflects it over the line y equals x. Or no, it rotates it 180. That's the same thing, isn't it? No, yeah. It sorry about that. Yes, it also rotates the shape 180 degrees. Because if you think about it, when you remember our instructions for rotating 180 degrees, it took it from xy to -x, -y. So that's the same thing as dilating with a scale factor of -1. So anytime your scale factor is negative, it also rotates the shape 180 degrees. So a negative scale factor also rotates the shape 180. And yes, Caleb, there is one more example that is coming up. Okay. So yeah, fun fact, rotating 180 is also kind of like dilating with a scale factor of -1. Or you can think of it as a negative scale factor also rotates your shape. Last example is going to be talking a little bit more about what scale factor looks like, but not in the coordinate plane. So last example, or at least last example on paper in our notes before we move on to talking about what it's going to look like in the homework. So let's say I've got a shape and another shape. That have been dilated about this point. And I will do my best to draw nicely. Okay. So let's say we've got a picture kind of like this. We have a triangle and we have a smaller triangle, and this is our center of dilation here. And then we might be given some information like this. Maybe this distance is 10. And this distance is 30. And we would want to know what is the scale factor and is it an enlargement or a reduction? So the shape itself is the orange part and the pink part. These are the two shapes. These lines going back to the center of dilation are just to show some distances to help us with demonstrating the distance to the center of dilation from each of these points. But yeah, it does look like some kind of freaky kite or something when drawn like this. Anyway, we want to know what is the scale factor, and we want to know if it's an enlargement or a reduction. So the important thing here is to notice which shape came first and which shape came second. So which shape is the original one? Is it the orange one or the pink one? And how do we know? Orange. Okay, we're guessing orange because I drew it first. There we go, Caleb. Orange because pink has that symbol, that apostrophe. We have P and we have P prime. Remember the one with the prime, the apostrophe, always comes second. So the orange shape came first. So yeah, if I'm going from orange to pink, it's a reduction. So we know it's a reduction. And then we want to know what the scale factor is. So let's see. So to figure out what the scale factor is, it's the dimension from the, so actually let's write this down. Scale factor is a dimension from the new shape divided by a dimension from the old shape. And it has to be two that correspond. It can't be like this one and this one or something. It has to be two that go together. So like 30 and 10. So in this case, it would be that P prime over P, that sort of idea. So it would be 10 over 30, which if I reduce that, we get 1/3. And that would be my scale factor. So the information we'd be interested in here is the scale factor and the fact that it's a reduction. Yes. making it smaller in size in this case, Sam. Nice. Okay, so that's kind of like what we were talking about on the first page after that problem, when we talked about finding the scale factor given the two shapes and taking the new shape dimension and dividing by the old shape dimension. That's the same thing that we're doing here. New shape over old shape, so 10 over 30 here. Okay, so that's another sort of problem that we might be asked to do. Any questions at this point? Any numbers we're not sure where they came from? Anything at all? Okay, if you do have anything, feel free to unmute yourself and say so, or type in the chat. Otherwise, I'm going to post the assignment and then we can go through a couple problems together and be done. Come on, internet. Yes, there is a video on yesterday's lesson, and it's posted on the classroom page right here. Okay, so today we have dilations with graphing and dilations determining the scale factor. Okay, so for this first one, it says graph with a dilation with a scale factor of 4 centered at the origin. So that means I'm going to be multiplying all of my coordinates by 4. So instead of over 2 up 1, it'll be over 8 up 4. For this one, instead of just over 2, it's going to be over 8. For this one, instead of over -2, it's over -8. And then instead of over -2 up 1, it'll be over -8 up 4. Okay, so that's the basics of the kind of homework problems we're going to see in that particular IXL section. If you see something like this with a scale factor of 1/2, that just means you're cutting all of your coordinates in half. So instead of over 10 up 8, we go over 5 up 4. Instead of over 10 down 10, over 5 down 5. Instead of over -8 down 10, over -4 down 5. Instead of over -8 up 8, over -4 up 4. Okay. There we go for that one. And then the other one that we have is dilations, figuring out the scale factor and deciding if it's a reduction or an enlargement. So this one's very important that you read the question. The purple shape is a dilation of the black shape. That means the black shape came first and the purple one came second. That means we're dealing with an enlargement because the purple shape is bigger. The green shape is a dilation of the black shape. What is the scale factor? So for this one, we have to count how long one of the sides is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So since this side is 15 and this side is 3, 15 divided by 3 is 5. So that would be our answer. Okay. At this point, you can stick around if you have questions, or you are free to head out and get started on the assignment. Yeah.